morning, everyone, and welcome to the 34th ETP4HPC webinar. I'm Gabriella, ETP4HPC's Office Manager, and today I will moderate the webinar instead of our usual host, Pascal, who is our Communication Manager. For those of you who are not familiar with ETP4HPC, we are a non-profit association that promotes European research and innovation in high-performance computing. We are private members of the European HPC Joint Undertaking, that is the organization in the European Commission that focuses on HPC. And our role is to propose research priorities for Europe in the area of HPC. So before we start, just a couple of practical information for you, a bit of housekeeping. So this webinar is recorded and you will receive the link to the recording should arrive tomorrow. The webinar is in listen-only mode, so you are not allowed to raise your hands, but you can use the GoToWebinar control panel that is illustrated here to ask questions or download the handouts. So you can submit questions clicking on this button to open the question panel. And I will take care of sharing your questions on the chat so that everyone can read and see them. And we'll handle all the questions at the end of the presentations, all the three presentations. So when we will have our question and answer session. In the hands-out session, you can find the slides that will be used today. So you can download them if you are interested in. So today we have three speakers, Dr. Michael Mams, Dr. Pierre Danet, and Dr. Valerio Frascolla. So Michael Mams is an ETP4HPC expert with a focus on the generation of strategic research agenda updates and future technical HPC roadmaps. He is now retired from IBM, but previous to his retirement, he held various technical and management positions in IBM system development. His main domain was pioneering new system architectures and designs during the last 15 years, mainly in the area of HPC. Dr. Pierre Danet is a senior consultant at the 6G Industry Association, which is managing the industry side of the Smart Network and Services JU. He is also representing the Alliance for IoT and Edge Computing Innovation, and he is in charge of the DestinE Paper 3, IoT and Networking. Dr. Valerio Frascolla works as Director of Research and Innovation at Intel and as Proposal Evaluator of the European Commission and the European National Funding Agencies. He has expertise in technology scouting, edge cloud continuum, connectivity, wireless system protocols, and ARM software architecture design, business and sustainability aspects of the impact of new technologies in diverse market verticals. He serves as Vice President of BDVA and is very active also in the IOTI and 6G AI associations. Valerio works as expert for the Destination Earth initiative on behalf of BDVA, being the responsible person for the data streaming part of the work. So this is our agenda. As I was telling you, we have the three technical presentations and then the question and answer session at the end. So I will now leave the floor to Michael Mams, our first speakers, to start the webinar.
Okay, so let me just make this bigger. I hope you can all see the charts. It's only very few charts, just giving the framing for the other two sessions. So we talk about Destination Earth. We talk about the project called the E380, which is a consultancy action of various associations, all working together in a so-called TCI, Transcontinuum Initiative. And you see those associations here on the right side. So besides the ETP4HPC, it's BDVA. Valerio is representing it. Alliance for IoT and Edge Computing, 6G SNS, Pierre-Yves is representing those two associations. Then we also have mathematicians on board. ECSO, which is the organization about cybersecurity, they talk next time. And we have also High Peak on board. So the idea was for the E380 as a project 2 years ago to basically come up with a kind of technical research agenda for Destination Earth. So it's basically a tuned SRA, if you want so, tuned to the specific needs of Destination Earth. This was the original idea. Instead of doing one big document, we decided to do various technical white papers. At the end, you see here domains addressed, those 6 white papers that were produced. And we're going to show you them almost all. I think the first one was already covered last time. And today you will hear the specifics about IoT and data stream, IoT and networking and data streaming. So the main purpose is to analyze the IT-related challenges of Destination Earth. It's all about Destination Earth running applications on EuroHPC systems. And while doing this, what kind of challenges have to be mastered? That's the question. Now, you will hear this in a second. Let me only come up with one disclaimer. So whatever you hear is the opinion of the authors of the white papers, so the associations being responsible for the technical information. It's not, let's say, the opinion of the European Commission. All the recommendations made are just recommendations. They don't need to be taken into account neither by ECMWF nor by the European Commission, so that you understand the framing here. Take what we say as the opinion of technical experts familiar with both their basic entities, their basic, let's say, domains on one side, and the challenges presented by Destination Earth. So, given this, Gabriela, I think we can go ahead. Gabriela?
Perfect. Yes, perfect. Sorry, I was speaking and the mic was shut off.
Okay.
Pierre, yes, so Pierre-Yves should be able to present now.
Okay, so I will share my screen, I guess. Okay, it's coming.
Yes, it's coming.
So, hopefully you, okay, so you see my screen.
Yes.
Okay, very good. Okay, so thank you for the invitation. So very glad to be there and to make a presentation of this work. So it was a long challenge, to analyze Destination Earth project requirements, as Michael say, and to provide recommendations. So just to show you where this paper on IoT and networking is focusing. So on 2 sides. So the first one on the left is regarding the collection of observation data. So here there is a link regarding the networking and the collection of information with a specific focus on fog computing. And in the other side, on the right side, it's for the end users who are experimenting. So the result of the Destination Earth digital twin. So it's the link between end users and the service platform. So So we have make an initial analysis of this Destination Earth project, and regarding IoT and networking, so we have decided to work on three specific points. The first one is on so the positioning of the pre-processing data fog, meaning when so we will collect observation data from different devices, try to see what we can put at the edge in order to provide a best-in-class so connecting services with the HPC platform. And the second one was on the Giant 5G interface. So Giant is obviously so the network which is used between all the different entities of the Destination Earth, meaning so the HPCs, the data lake, the service platform, and so on. But obviously, so they need to have an interface with this network in order to access to end device IoT, but also to end users where they are consuming so the result of the Destination Earth. And the last one was in a future scenario, try to identify what are the actual weaknesses of this 5G with regard to Destination Earth, and that we can take into account in the next 6G network and maybe the next version afterwards. So regarding the first one, on the computing-based positioning of pre-processing data fog, so the idea is to optimize so the data flow transfer between the different observation so device. So mainly today it is satellite or aircraft or balloon and so on, which are usually used to collect this information data. But in the next future, or in the future, so we can have some other type of devices which could provide additional information, such as mobile phone or drones or weather forecast station and so on, and so which are connected with other type of network. And in order to be sure that so all this huge amount of information of data are coming in the right way and the right time into the process, so there is a need somewhere to better understand what pre-processing could be put at the mobile edge, at the deep edge, at the device edge. So there are several locations, and so the idea is really to find the right place for each of these pre-processing function. So just to show you granularity of the edge computing, you know, there are several possibilities from what we call the micro edge to the cloud, and depending the functionality, specific functionalities such as compression, such as security, such as pre-processing, so we can position this function at different location. And so the idea is really to find the most relevant location for each of these functions. So the recommendations that we have provided are the following ones. So they are divided in three terms, the short, mid, and long terms. For the short terms, so what we propose is that the data compression and decompression should be used to optimize the data transmission. So it's something which is key because there are a large amount of information and surely a lot of video, 3D and so on, which need a lot of bandwidth and network capacity. And somewhere it's important, you know, to use a good algorithm that could be positioned at the edge in order to optimize the transmission. And obviously to take into account the capacity of the network in terms of bandwidth, latency, and energy consumption. At midterm, so Destination Earth will introduce a new source of observation data, such as sensors, such as mobile phones, such as cars, and so on. So there will be a need also to provide and to put in place so fog computing solution in order to optimize again so this data transmission. And so the idea is that these fog computing capacities could provide an intermediate layer between observation center and so the data lake and what Destination Earth is working on in order to feed so the digital twin model. And at long term, so it's the same way. The idea is really to continue to add some new sensors, some new source of information in order to have an accurate model of the digital twin, and so using so this function in order to accelerate and to put in place so better pre-treatment at the edge. And sure, so to put in place also maybe AI algorithms at the edge also in order to make pre-processing and help to have a more so powerful overall system. So that's more or less the main recommendations that we have provided regarding so this specific challenge. Regarding this challenge 2 and the interface between GÉANT network and the 5G. So GÉANT today is mainly used, to make the connection between so the observation data coming from the satellite network or aircraft and so on through the MEDSAT services. And so, but there is a need, to make, as I said before, an interface with the public network in order to provide some additional sources, but also to bring to end users so access to the service platform. And so the idea there is to develop point of access between the GÉANT network and so the public networks, so the 5G, but the next 6G as well, in order to offer the best-in-class so seamless services between these different entities in terms of bandwidth, latency, QoS, security, and so on. Knowing that in the future, so they could so bring some new type of user interface using X-reality, for instance, in order to bring better experiences to the end user. And so that is something that need to be taken into account. Just to let you know, so different connectivity between the different platforms which are used in this project. So you have the source, the source coming from a MEDSAT, Copernicus, or WNO, and also with the future 5G network, so collecting data from IoT and so on. You have so the data lake, the acquisition system, and then so you have the connection with a different EuroHPC center. And GÉANT is mainly operated all these different interface. We just have to have here the interface with 5G networks, the public network, and here with the end users. So the recommendation regarding this point is through 3 holes as well, short, mid, and long term. So as short term, so the idea is really to begin to work closer with GÉANT in order to see what are the specificity of Destination Earth in terms of compression, decompression, on all this type of stuff, and see how so the point of presence could take into consideration in the best manner this traffic of data. Then at midterms, it's when so Destination Earth will include as well so new so observation sources. So try to see how so yes this point of presence for GÉANT could use the most relevant slice. So in the network, in the future network. So there are some specific configuration of the network which are able to be provided to end users regarding different topics such as machine-to-machine communication, so such as ultra reliable communication or so mobile broadband. And so we can use on this point of presence the most relevant slice in order to be the most so powerful possible. And so at the long term, so same, so using the artificial intelligence, so that could be developed, you know, at the edge. So it's also something that we need to take into account. It's in the interface between the different networks, public networks, general networks. Then the last challenge is on so the potential weakness of 5G. So as I said before, 5G and the future so XG version of the network will provide so better connectivity, better flexibility, and so on. And it could happen that destination Earth could take advantage of this new so network capacity in order to bring a better better services. And if we look to the overall connectivity, so you have what is used today, you know, this part with the satellite, with the Earth observation satellite, with the ships, aircraft, balloon, and so on. And in the future, so they will add all these different types of devices, such as so low orbital so satellite, cars, mobile, drones, and any device that could complement so the observation provided by the regular system. And here, so there is a number of interface that need to be described and need to be developed in order to have the best-in-class system. So what is important also to understand is that in the future network, so there will be the integration of the non-terrestrial network and terrestrial network, so satellite network, you know. And it's very key for this type of application because in the next future, so from the destination of Earth point of view, there will be no so differences, whatever so the different observation so device are connected from satellite or from terrestrial network. And so it's something that needs to be considered in order to bring so the best services, whatever so the end device is connected. So we have here, you know, a list of different observation devices which has been identified. So the type of connectivity which could be used, and so meaning that all these different connectivity systems need to be interoperable, and so use a single type of data description in order to be the more efficient as possible. And the recommendation here is really to try to work together between ECMWF partners and the smart connectivity, smart network and services members in order to better understand what are the benefits of this new satellite communication, and also to try to study, you know, some new integration of different type of system and capacity of the future network. And today and tomorrow, there will be also a need to put in place this specific working group. So that's our recommendation, you know, with all these experts all together in order to find the best solution in the future. So just to finalize my talk today, so regarding the main takeaways that you should have. So first is so the decentralization of observation data computing function at the edge. It's one of the possibilities that could be used to help, you know, to give a better services. Use of so satellite and terrestrial connectivity, mobile connectivity, whatever. So the user and so the observation system is located. Use of compression, data compression and decompression at the edge to optimize that the bandwidth and the latency, and convert the observation data in a single format at the edge to optimize integration. So that more or less, you know, the key points that I would like to share with you today. And so I think I'm in time, and so of course I can answer to any question if needed. So thank you for listening, and I let the floor to Valerio.
Yes. So Valerio, the floor is yours. If you want to start the sharing. And please unmute.
You should see it right now. Can you confirm?
Not in presentation
I'm going to
mode.
presentation mode right now. Yes. Okay, you should see it. Is it right?
No, it's still in normal mode.
Oh, I have it in presentation mode. That's funny. So let me share my screen instead of my application. Of course, we did it before and it worked, and now it's not working. So give me a sec.
Always.
Yes. So I will share my other screen now, and then I go to presentation mode, and you should see it. Can you confirm?
Yes. No, this is the other one. It's your.
Okay. So it's the other
Yeah,
screen.
we did a lot of trials, but in the end, there is always the
So
live effect.
let's go for the second screen then. Okay. Options are finished, so you should be
Okay,
able to
let's
go
keep
now.
it as it is. I think it's okay.
Okay. Can you see
Yeah.
it? Yes. Okay. So good morning, and sorry for this small hiccup. I was already introduced, so I don't need to talk about myself, but I would like to mention 4 other colleagues that were really instrumental to create this common endeavor, which was analyzing the data streaming aspects in a very interesting project. And actually, it's a program, I would say, because it's spanning several years, called Destination Earth. So I would like to mention Maria Perez, Dumitrio Roman, Cole Titi, Gabriel Antonio, and Sai Narasimha Murthy. We had a very interesting and exciting work together in order to finalize the 50 plus pages document that we shared with Destination Earth. This was driven by the Big Data Value Association. This, I mean, the data streaming aspects. And for that, let me just spend 1 minute telling you what the association is. So it is called Big Data Value Association. I have the big pleasure of being elected for the second time vice president of it. And it's an industrial-driven, international, not-for-profit organization with more than 250 members. And we have a set of objectives, which I summarize here in 4 main one: to boost data and AI research, development, and innovation for the European ecosystem, mainly. Develop an innovation ecosystem, in fact, that enables and accelerates the data-driven and AI-enabled digital transformation. We want to foster excellence in the European data and AI research. And then we anticipate, trying to lead and keep up with dynamic change that the data and AI worlds bring together. So BDVA organizes, among others, each year the Data Week and the ECMWF event. It was 2 weeks ago in Budapest, the last one. And let me therefore tell you, please join us in December in the third event of the Data Week. It was split in 3 times this time in Luxembourg. It will be in the 10th of December, together with the Data Summit in Luxembourg happening in the 11th of December. So very happy to meet you there, those of you who would like to come. Sorry for my voice, but I'm just out of a few days of illness and my voice is still to recover. So let me try to set the scene on what we call data streaming so that we are all on the same boat. Of course, in the documents, there are a lot of more background information that you would need to know to clarify exactly what we're talking about. Pierre-Yves already shared a high-level view of the system, so I'm not sharing that again. I'm more entering now into a bit more of detail. So we call data streaming in this specific framework of Destination Earth the continuous transmission of data from a source to destination. That's the basic definition. But the point is that the refinement of it, which are the Destination Earth specificities, is that there is a continuous generation or a potential continuous generation of packets of data that can range from very small to very big. There is a real-time request to keep this data current because there are digital twins involved. And of course, you know how important it is to be almost real-time. The data consumers can be humans or application or even digital twins. It depends a bit. I would also add AI. in a few years probably. And then the stream ranges from milliseconds to hour, depending on the application. And data streaming is used when real-time analysis is required, right? So there are several vertical sectors that would require it, like manufacturing, autonomous vehicle. I'm not entering in those. They should be familiar to most of you. And there are a lot of challenges, and I picked 3 of them. The data consistency in a very complex system with several subparts, scalability of the proposed architecture and of the proposed data streaming procedures, reliability of that, and blah, blah. We will touch upon a few of those in the next slides. So let me give you a very simple but telling high-level representation of what we are talking about. Where are these data streaming moving between the different objects of the architecture from a very high-level perspective? So you might say that there are several external sources, sensors, satellites, and whatever you want, that stream into the data lake, which is the central block here. The data lake itself has data streams towards the different HPC clusters that are part of Destination Earth. At the beginning, there will be 1, then 2, then different ones of them. And the data streams are also happening between the HPC centers, because depending on the task and on the application, data streams can be handled by 1 or even more HPC, depending on the load of a single HPC. And then the data streams are supposed to come back from the HPC to the data lake to be then streamed again to the core platform, which is in this setup the main interface towards the external worlds, namely the final users or the applications of the Destination Earth system. The streams may include quite a vast amount of different items, from meteorological data to ephemeral data to results produced by digital twins. So, we were chartered to come with something that could be deployed in different ways depending on the need of the specific application, in the need of the specific setup of Destination Earth. And so we spent more than 1 year actually among the 5 of us, as I said, but also working with the other white paper responsible colleagues in Destination Earth in understanding what would make more sense to concentrate first. Also considering that one of the main open point and the challenge that we face in the data streaming is the data volumes are very significant. And with that, I mean petabytes per day operational, hundreds of terabytes per day between the data bridges that are here and there in the infrastructure, and tens of gigabytes per day regarding the data lake to the core platform. So you see, it's not a trivial pursuit, this one. Now, let me enter a bit more into the focus of what we want to change according to how it works as of today. So on the right side of my slide, you see a 2 block. The block on the left is how it works today, where you have a digital twin model that stores data on an HPC system, and it then communicates and takes input from consumers. We want to move from that model to an architecture or a model that has a digital twin that directly streams data towards the consumers. Okay, so it's quite a different shape it's quite a different change in shape of the way the data is moving among the different entities. And as I said previously, data will be needed to continuously be transmitted among the different entities. Notification depends on the model and of the architecture. I will detail it a bit later. Not all data streams will be stored. Most will be just produced and processed on the fly. That's the idea. Data can be buffered for a short period, and the periodicity of the stream created can vary a lot, but mostly is more than a few seconds. So a couple of characteristics from the digital twin producers and the digital twin consumers, which will be the main actors, let's say, in the data streaming game, if you allow me this analogy. So there are big models, and at the moment there is a plan to have up to 5 big digital twins. They forward data from forecast or simulation. They stream data at into a predictable rate. And we expect a homogeneous producer with a standardized production protocol, of course. Data produced by a digital twin can be input to other digital twin, and I say multiple ones, could be one or could be more. And the format of the raw data produced by the digital twin is open. It could depend on the application, it could depend on the specific digital twin, it could depend on the implementation of that digital twin in a specific HPC center. And for the consumers, there will be a lot of consumers. We assume that there will be a lot of users asking data from this destination system. They cannot request data at certain time, or they could, we do not know exactly. We expect different consumption protocol with different frequency. So you see the variability of the request is quite high, and we have to take care that all of those can be sustained and fulfilled. And consumers could also store data if that is needed from their specific application. There are aspects of fault tolerance as well, of throughput and security of access right. So, there are other white papers that take care, for instance, the one that Pierre-Yves mentioned before on connectivity and IoT, but there is also another one on security aspects. So we have not had a deep dive on security aspects of access right, even though access right is one of the things that are key in data streaming. So we collaborated also with the EXO, mainly with the EXO Association in those aspects. But I'm not discussing them today because there will be a session from EXO later on scheduled before the end of the year, I guess. I don't want to enter in the details. Let me just pick one bullet per macro topic. So for the fault tolerance, I would say that the reliability of data is very key, and we assume that there is a high reliability of data in a first instance, but then, Destination Earth is a program spanning several years. So as you will see in one of my last slides, we are coming with some recommendation on the short term, mid-term, and long term. So for the short term, we assume that fault tolerance is not a key concern. It will become a big concern when the basic things will be fixed. And so in the mid and long term, fault tolerance will be taken as one of the highest concern. Regarding the throughput, well, actually, we have to take care about the HPC system throughput, right? Because these are the actors and the digital twins as well we have to work on. And for the security aspects, of course, the corruption of the data in the file system when such huge amount of data is to be dealt with might be the thing that they would like to cherry pick. Now, we structure our feedback in the document according to 4 main areas: architectural choices for stream processing systems, data stream creation and access control. And for each one of these are the first 2. In the next slide, you will see the other 2. And for each one of these, there are some sub-subjects that we concentrated our attention on. And in my next slide, I will pick among some of those sub-subjects to give you a bit more of color of what we have. So the first 2, as I said, is architectural choices and the string creation and access control. The next 2 are compression and encryption. This is the part that I'm expert on. And the streaming infrastructure and consideration is the 4th one. So let's focus now on the architectural aspect in data streaming systems, because I think that most of the audience of this seminar might be interested to architectural aspects. So we have analyzed the pull versus push based processing model. It depends how you see how things should move into the system. Is the producer pushing as soon as it has done with the processing, or is the consumer asking as soon as the application wants to see something? So there must be a mix of this, and depending on the application could be either one or the other, or a mix of both. And then quite interesting also from the research point of view aspect is the homogeneous versus heterogeneous and centralized versus federated approach for the system. With homogeneous and heterogeneous, of course, we talk about the hardware and the software pieces. It could be a GPU, it could be a CPU, it could be a hardware accelerator. In middle term, it could be a neuromorphic chip as well. So, there's a lot of heterogeneity in the processing mechanism, but also there is heterogeneity in the software that is needed, not only on the kind of digital twins that are deployed, but also on the kind of software, on the database that are used to store data, and all these other aspects related to software. So we would like basically to move from a centralized model that you see bottom left in my slide to a more federated model that you see more on top right of my slide. And this follows also the streaming research that you have might seen in these last 10 years, federation, and all these different aspects of machine learning and AI that are distributed among the system, because as the system gets complex and more complex, you need to have a different approach, and the centralized one might not fit mostly all cases. Other aspects to consider is the scalability. Of course, when we are talking about such a huge amount of data and a different number of digital twins and a data lake and an interface and different sources, the scalability of the approach is key. Also considering that depending on the demand of the application and on the final users, it might be a moment or hours where not so much happens, but there might be instead occasions where there are multiple users that will ask at the same time destination Earth to provide an input, or let's say the output towards them, and they see it as an input. The reliability is key, of course, when dealing with all these processing steps. Real-time processing or near real-time processing is a very important aspect, because we need to be able to align all the digital twin content with the real life content of what those digital twins are representing. I'm thinking, for instance, on an emergency scenario where for the Hamburg mayor would like to see what's happening with a tornado or moving towards his or her city, and see what can be done, what are the forecasts, for instance, so that the real time is quite key. Security I mentioned, and then fault tolerance, I mentioned that as well before. Now, push or pull based, I come back to this because there are a couple of scenarios that I want to highlight. For the push based, the possible scenario is, for instance, continuously generated data from digital twin to the data lake are sent. And for the pull-based scenario, instead, it's a consumer-initiated stream where end user invoke a data service that is mainly driven by the digital twins. Homogeneous versus heterogeneous, centralized and federated. I mentioned that before. Control and orchestration. This is a quite broad area of even research, I would say. There are several approaches, Lambda, Kappa, event-driven, and cloud. We don't have the time to dig into those, but each one of them have pros and cons, and depending on the specific scenario, we could pick one or the other, or a mix of them. And then for required capabilities, we have to prioritize, depending also on the need of the application, which one we want to first deliver. It's more reliable, it's more scalable, it's more maintainable, and it's more fault tolerance. It depends a bit. I think I have to speed up a bit. So now let's move to the second chunk of activity, the data stream creation and access control. So as I said, there are different data sources, and there will be different platforms of data stream entities, and the integration of all of them will be a key important factor, because the effective integration will make a difference from a working system to a so-so working system. Data producers and consumers, as I said, at the moment are supposed to be up to maximum 5 digital twins, which are very complex, by the way, but the idea is to also scale them to a higher number. Testing and optimization is one key aspect as well. And data archiving and storage, even though, let's say, not all application will request to store the data that is being processed, there are some that will, and so we have to take that request into consideration as well. Regarding the compression and encryption, I want to touch on 4 main points. Basically, depending on the needs of the setup of the different digital twins on the different accelerators and pieces of hardware, you might want to create an analysis that carefully defines whether GPUs are needed, whether CPUs would be perfectly working, or dedicated hardware, or even FPGAs if you want to have a system that is capable of, plug in and plug out new algorithms, plug in and plug out new security mechanism, protocols, and so on. Regarding the alignment with the other system-level security aspects and the international regulation, this is a quite broad and still open topic, because the idea is that Destination Earth is supposed to be a service that is delivered taking the processing capability from different HPC centers, and these are spread in different member states of the European Union. Ideally, one could also be in Switzerland or in the UK, so even outside of the European Union in the middle term. And the idea would be, okay, how can we guarantee that the regulations of the different member states and even of associated partner to the European Union can be met? Meanwhile, we are processing in real time or near real time the data streams. This is a quite big open point. The balance between energy consumption as performance is a key aspect as well. More and more we have to come with the balance because energy will cost probably more and more, and we have to cope with that constraint. And then assess the need for compression and encryption, because if you are within a single HPC and you are performing a data streaming there, you might not need to, for instance, encrypt data because your environment or island is considered secure enough not to request for encryption. Compression instead might be used most of the time because compression reduces the number of bits and that are transmitted, and of course you have to balance the compression demand of the chips versus the reduce in bytes that you will get. Finally, the last part, and then I have my last two slides with the recommendation, the infrastructure consideration. So I just want to pick the second one here. The use of non-volatile memories as burst buffered in data nodes, because this is quite an interesting recent approach. I wouldn't say completely new, but it's a recent approach, more and more used, because we are talking about very high throughput and low latency systems. So the NVM approach is one to consider for sure. And then to stage the required data from the lower storage tiers to be used their workflows in a way that is more timely and efficient. So the idea would be, as you know, that there will be a memory hierarchy involved, and the way that it works will make the difference on the capability of the system to perform or not. In fact, the last point is in use of hierarchical storage managers, and there are a couple of proposals that we have made. I just want to pick the one that we said Hestia could be used, but let's say there are others that we touched upon in the document. So some recommendations. This is an excerpt of the recommendation for the 4 main blocks of our activities, and the color code is in green is 1 and 2 years, in orange 3-4 years, and in deeper orange is 5+ years. I didn't want to use a red like the traffic light because it might have been taken in the wrong sense. So I am not reading them all. You have the slides, you can read them. I picked just one per macro block. So let me say that for the architectural choices, I would say that the AI-driven optimization is something that in the very close term needs to be taken care of, because the AIification of specific mechanism can really make a difference. Regarding the string creation and access control, I would like to pick the implementation of semantic technologies, even though it's not an immediate suggestion, but it's a midterm suggestions, because actually that can make a big difference. For compression and encryption, I would like to pick the inclusion of FPGA GPUs and neuromorphic chips together with the normal hardware and the normal CPUs, because this will allow on the one end more flexibility thanks to the FPGA, on the other end a much better resource consumption, for instance, thanks for the neuromorphic chip that, as you might know, in some specific scenario might have even a 10 times reduction in energy consumption for the same use case. And for the last block, infrastructure consideration, I would like to stress the introduction of the data nodes in the digital twins. Now, my last slide is listing some other topic to consider that we have touched upon in our document, but not to the level that we would have liked due to resource constraints and time constraints. And I will pick again 2 of them, which is the interoperability standards. You know, it's a plethora of standards out there, the ones that will be deployed, the ones that need to be fulfilled and be compliant with. So do we need new standards to make this work or not? I would say no, because there are already a lot there, but the interoperability between standards when we touch on so many different aspects of a complex system is a key topic. And the energy consumption, I never stop stressing this point once again. And then, of course, the connectivity issues and the security issues together with the other white paper. So I'm done with my presentation, and I would be happy to take questions if there are. Thank you. Gabriela, I hand over back to you.
Thank you very much, Valerio. So it's now time for the questions. So I invite each of you to ask questions if you have any. And as I was saying, you can find them in the control panel. There is a button for questions, and you can write them there, your questions. In the meanwhile, may I ask for the energy consumption? So I don't know who of you, but feel free to answer. So do you think the energy consumption will be higher for maybe compressing the data, or just for their normal, let's say, processing for according to the applications? Have you any idea of which is the share between the different part of the scenario?
I can start if Pierre is okay with that.
Yeah, please go ahead.
Yeah, so, well, the energy consumption is a quite hard topic to crack, because depending on where you put the focus in such a complex system, it means different things, right? So, for instance,
Valerio,
Yeah.
we can't hear you. Hello?
He's
am I
coming
back?
Yes, you're back. Yes.
Yes.
I'm sorry, something has happened to my connection. Okay, yes, you see me, I see you. I will keep it short. I was saying that looking at the encryption and decryption and compression, these are quite energy in need of energy processes, and due to the huge number of data that is involved, there will be the need of a careful assessment whether compression is needed. As I said, the balance between what you get with what you have to spend to get there. And we don't have yet those digital twins fully deployed and the system yet running that we can make this comparison. But we said that this is one of the first things they have to do in order to come out with an energy balance and an energy figure. What is the threshold that they can afford? Which is the minimum threshold that they can get to? What is the maximum one that they can go to? And depending on this window, then they will decide whether encryption, decryption, and compression mechanism can or will be used.
Thank you very much. I see no other questions for the audience.
So maybe let me ask you two questions here. Just a recommendation. So those two topics are not really at the center of, let's say, traditional HPC discussions. So when I think about our SRAs in the past, since I was driving 5 of those, for instance, IoT networking did not play a central role. We always assumed, okay, we focus on the design of the HPC systems, and the network is there, it exists. Yeah? And and the same is true for data streaming. I mean, data streaming in hyperscalers in the commercial cloud environment is absolutely a daily business. Data streaming in the context, Valerie, that you showed here in HPC environments, I think in most cases is new, but it's coming. So let me ask you first, Pierre-Yves, when you think about the many of things the many of many elements that come with 6G, two questions here. Number one, did you find anything that Destination Earth is requiring as something totally new to the set of networking aspects that you bring into 6G, or is it just a matter of using already planned elements in a maybe new way?
Thanks, Michael. Yes, so we do not find any weaknesses or any problem with the 6G. The only problem will be in the real application, because as Valerio said, so there will be a huge amount of data that will be going from one entity to another one, and so it's a very specificity of this destination Earth project, and so we'll see if the networks are really ready to manage, such amount of data. That's really a point that need to be checked. But on the paper, so normally it should be okay.
Mm-hmm. Okay. And how about the time scale for introducing the functions that you talked about concerning 6G?
Well, 6G normally will be deployed by MNOs, mobile operator or operators, by 2030. But during this period of time between 5G, there is a 5G, what we call standalone 5G, which is based on the existing 4G core network, and the standalone 5G, which come soon now, which is a real 5G network with a specific functionalities that could bring additional capacities for covering such applications such as destination Earth. But what is key to understand as well is what I know is that destination Earth is very useful project to better understand how HPC could bring some services to end users. But if tomorrow you want to open, HPC center as a service for any end user, not only for specific research project, but for any SMEs who need, at one time specific computing capacities. So you need to open it through public networks in order to aggregate data from sensors or from databases, and also aggregate the specific application that need to be run on the HPC center, and at the end, of course, get back the result of the processing. So, and in each of these different activities, so you need to manage connectivity with public networks, and it's something that could be interesting, to study.
Yeah. Okay. And you mentioned that it's required that, let's say, the different disciplines work closer together. So I hope this is going to work out in the future.
Yeah.
And also maybe we have a CSA or something like this coming up, where we all could play a joint role. Now, Valerio, remember we discussed, let's say, the streaming approaches in the cloud environment, and many of the currently known mechanisms and processes and applications are coming from that environment. Now they have to be applied to the HPC arena. What kind of new challenges did you encounter when you were working with the team that was previously mostly familiar with elements for the cloud environment?
Well, one of the points that was on one hand more interesting, but on the other hand more difficult to crack, is the heterogeneity of the actors here. Because when you are a hyperscaler, you are a company and you own everything within your company. You deliver a service, but it's all owned by you. Here we're talking about different HPC centers located in the different member states of the European Union, different software that have to plug together, different piece of hardware. Each HPC might have its own quirks. They might have their own accessing capability. They might give only a percentage of their work hour to the external destination Earth. So all these kind of aspects that are not strictly related to a specific technology, but in mixing technologies together and making them work effectively, is what I think would give the biggest headache to those that will really implement Destination Earth. So to summarize, between member states, there are different legal also obligation, and the differences between the hardware and software pieces that will compose the complex system.
Okay, Yeah, you're right. Thank you. So,
Okay,
Gabriela, back to you.
we have one question from Roberto Digio. So the question, I'm putting it in the chat and I'm going to read. The architectural aspects implies that the peer-to-peer connection between DT and consumer. Have you think about introducing the concept of mesh network?
So in reality, the peer-to-peer doesn't happen the way that was said, because there are two levels of, let's say, checkpoints between the final user can get the digital twin output. This is what we call the core platform. You might remember in my presentation, there was a block called core platform, bottom right. You can see it later on. And basically the digital twin go through the data lake, through the core platform towards the final users. So it's not really a peer-to-peer collaboration. Yeah, mesh network, but you know, the point is that this is an architectural aspect, but I would say that there are other key aspects to be solved before we can enter there. And if you remember, in one of my other topics to consider is this inclusion of fog and edge in a proper way. And mesh technologies can be seen in that aspect of the work that we highlighted needs to be done. We have not worked on that in our paper because we didn't have the time, but we highlighted that as one of the topics that we have to spend time on. We as a community, I mean.
Okay, so thank you very much. So I think we have finished our time today. Thank you to our attendees and thank you very much to our speakers for your availability. And we keep in touch for the last webinar of this year for 2024 series of ETP's webinar. It will be in more or less 1 month time, and it will focus on the cybersecurity aspects of destination Earth and what's next for destination Earth. So thank you very much, everyone.
Thank you very
Bye-bye.
much.
Thank you.
Bye-bye. Take care.